Hi guys, welcome back to engineeringtalks.com. In the previous videos, we discussed Laplace transforms, inverse Laplace transforms, their properties, then the method of finding out the inverse Laplace transforms of the functions using partial fractions, then Laplace transforms of derivatives and integrals. And finally, in the last two videos, we dealt with the topics differentiation of Laplace transforms and integration of Laplace transforms. Now let's move into the topic convolutions. So what does this convolution mean? Suppose we are given two transforms f of s and g of s whose inverse Laplace transforms f of t and g of t are known, then we can find out the inverse Laplace transform of the product of f of s and g of s, that is Laplace inverse of f of s, g of s. We already know that Laplace inverse of f of s is f of t and Laplace inverse of g of s is g of t. So Laplace inverse of the product f of s into g of s, that is Laplace inverse of f of s g of s, is denoted by f star g of t. And this f star g of t is known as the convolution of the functions f of t and g of t. So convolution is nothing but the inverse Laplace transform of the product f of s and g of s. That is Laplace inverse of f of s, g of s is known as the convolution of the functions f of t, g of t. So let's see how we can solve the problems using this property of convolution in this video. And don't forget to like, share, subscribe and press the bell icon. So, if we are given two transforms f of s and g of s whose inverses f of t and g of t are known, then we can find out the inverse Laplace transform of the product f of s, g of s. That is, Laplace inverse of f of s, g of s is equal to f star g of t, where f star g of t is the convolution of the functions f of t and g of t. We can obtain the values of the functions f of t and g of t by taking the inverse Laplace transforms of f of s and g of s separately. And finally, we can obtain the value of f star g of t by integrating the product f of t minus u, g of u within the limits 0 to t. In the function f of t, if we substitute t minus u in the place of t, we get f of t minus u. And in the function g of t, if we substitute u in the place of t, we'll get g of u. So, integral 0 to t f of t minus u g of u du is f star g of t, and it is the convolution of the functions f of t, g of t. Now, let's see the commutativity of convolution. That is, f star g is equal to g star f. Now let's see how we can prove this. F star g of t is equal to, we all know, integral 0 to t f of t minus u g of u du, right? So let's put this t minus u is equal to v. Then we'll have v is equal to t when u is equal to 0 and v is equal to 0 when u is equal to t. These integrals, that is from 0 to t, these limits, it is for commutativity of convolution. That is f star g is equal to g star f. Now let's prove this. F star g of t is equal to integral 0 to t f of t minus u g of u du, right? Now let's put this t minus u is equal to v. Since we are changing the variable u to v, we have to change the limits also accordingly. So, when u is equal to 0, we will have v is equal to t, that is t minus 0 is equal to t. And when u is equal to t, we will have v is equal to t minus t, that is v is equal to 0. Now, from this we will have u is equal to t minus v and du will be equal to minus dv. Now let's substitute all these values in this equation. Therefore, equation 1 becomes f star g of t is equal to minus integral t to 0 f of v g of t minus v dv. That is, in the place of t minus u, we substituted v. In the place of u, we substituted t minus v. And in the place of du, we substituted minus dv, and we have taken that minus outside. Now, minus of integral a to b is given by plus integral b to a. That is, minus of integral t to 0 is equal to integral 0 to t g of t minus v f of v dv. Now, this is of the form integral 0 to t f of t minus u g of u du, right? We have f star g of t is equal to this. Therefore, integral 0 to t g of t minus v f of v dv is equal to g star f of t. Similarly, we have other properties of convolution, that is f star g plus h is equal to f star g plus f star h, and f star g star h is equal to f star g star h, and f star 0 is equal to 0 star f, which is equal to 0. Now, let's solve a problem. We have to find out the inverse Laplace transform of the function 1 by s square into s minus a. Here, we can write f of s is equal to 1 by s square and g of s is equal to 1 by s minus a. We have just split the function into two transforms of the functions. So, f of s is equal to 1 by s square and g of s is equal to 1 by s minus a. Then, from this we will have f of t is equal to Laplace inverse of f of s, which is equal to Laplace inverse of 1 by s square, that is equal to t. And g of t will be equal to Laplace inverse of g of s, which is equal to Laplace inverse of 1 by s minus a, which is equal to e raised to at. Therefore, Laplace inverse of 1 by s square into s minus a will be equal to integral 0 to t f of t minus u g of u du. We have f of t equal to t. Therefore, we have to substitute t minus u in the place of t in f of t. So, f of t is just t. Therefore, we will just substitute t minus u in the place of t, and we have to substitute u in the place of t in g of t. G of t is equal to e raised to t. So, we will just substitute u in the place of t here. So, e raised to au du, which is equal to, now we will split and write integral 0 to t e raised to au du minus integral 0 to t u e raised to au du, right? Now, t is constant here. So, t integral 0 to t e raised to au du minus integral 0 to t u e raised to au du. Now, we have to find out the integration by Now, let's see how we can find out the inverse Laplace transforms of functions using convolution property. Here the function given is 1 by s square into s minus a. Now we can split this function into two transforms, f of s and g of s, and write it as f of s is equal to 1 by s square and g of s is equal to 1 by s minus a. Therefore, f of t will be equal to Laplace inverse of f of s, that is Laplace inverse of 1 by s square, which is equal to t, and g of t will be equal to Laplace inverse of g of s. Therefore, Laplace inverse of 1 by s minus a, which will be equal to e raised to at. Therefore, Laplace inverse of 1 by s square into s minus a is equal to integral 0 to t f of t minus u g of u du. Now, we have to substitute t minus u in the place of t in the function f of t and u in the place of t in the function g of t. Therefore, integral 0 to t, here in the function f of t, we have t. So, we just have to substitute t minus u in the place of t. And the function g of t is equal to e raised to at. So, we can substitute u in the place of t here. So it becomes e raised to au. So integral 0 to t minus u e raised to au du. Now we can split and write it as integral 0 to t e raised to au du minus integral 0 to t u e raised to au du. Now this integration is with respect to the variable u. So t is constant here. We can take this outside. So t integral 0 to t e raised to au du minus here this integral 0 to t u e raised to au du is of the format integral uv dx. So integral uv dx is equal to u into integral v dx minus integral of dx into integral v dx the whole dx. So we'll substitute that formula here. So in t integral 0 to t e raised to au du minus of u into integral of v, that is e raised to au by a minus integral of derivative of u, that is d by du of u will be equal to 1 into integral of v, that is v is equal to e raised to au here. So integral of e raised to au is e raised to au by a du within the limits 0 to t. Now t integral of e raised to au is e raised to au by a. So t e raised to au by a within the limits 0 to t minus u e raised to au by a minus, now here we have to take the integral of e raised to au again. So it becomes e raised to au by a. So in the denominator we will have two a's. So a into a becomes a square. Therefore minus e raised to au by a square within the limits 0 to t, which is equal to, now we can take this a in the denominator outside, that is t by a into e raised to at minus e raised to 0. That is after applying the limits we will get e raised to at minus e raised to 0 minus, now we will apply the limits here also, that is t e raised to at by a minus e raised to at by a square minus, now we will put 0 in the place of u. So the first term becomes 0, that is 0 minus e raised to 0 by a square. Now this becomes equal to t by a e raised to at minus 1, that is e raised to 0 is 1 minus of t e raised to at by a plus, that is minus of minus becomes plus. So plus e raised to at by a square, and here inside the bracket it will be plus e raised to 0 by a square, that is plus 1 by a square. Now when we take this outside the bracket it becomes minus 1 by a square. Now this becomes equal to, now we can cancel this t e raised to at by a and minus t e raised to at by a. Now what is left is minus t by a and 1 plus e raised to at by a square and 1 minus 1 by a square. Now we can make the denominator equal to a square. So it becomes equal to e raised to at minus 1 by a square. Let's see how we can take the inverse Laplace transform of the function 1 by s square plus a square the whole square using convolution property. Laplace inverse of 1 by s square plus a square the whole square can be written as Laplace inverse of 1 by s into s by s square plus a square the whole square. That is just multiplying and dividing by s. It's effectively the same as 1 by s square plus a square the whole square. Now why we have made this change is that now it is possible to split the function into f of s and g of s. So that is why this rearrangement has been made. So f of s is equal to 1 by s and g of s is equal to s by s square plus a square the whole square. Now we can get the f of t and g of t functions. F of t will be equal to Laplace inverse of f of s, that is Laplace inverse of 1 by s, which will be equal to 1, and g of t will be equal to Laplace inverse of g of s, that is Laplace inverse of s by s square plus a square the whole square. Now Laplace inverse of 2as by s square plus a square the whole square is equal to t sin at. If you have any doubt in this, please watch my video on differentiation of Laplace transforms. I have explained this in that video. So Laplace inverse of s by s square plus a square the whole square will be equal to t sin at by 2a. Now Laplace inverse of 1 by s into s by s square plus a square the whole square is equal to integral 0 to t f of t minus u g of u du. Now we have to substitute t minus u in the place of t in the function f of t.
f of t is equal to 1. It's a constant. So put it as it is. Now g of u will be equal to u sine au by 2a. G of t is t sine at by 2a. So g of u will be equal to u sine au by 2a du. This will be equal to integral 0 to t u sine au by 2a du. Now we'll take this constant outside. So it becomes equal to 1 by 2a integral 0 to t u sine au du. Now this is of the format integral uv dx. So 1 by 2a into u into integral sine au. Integral of sine au is minus cos au by a within the limit 0 to t minus integral 0 to t derivative of u, that is d by du of u is 1 into integral of sine au, that is minus cos au by a du. Now 1 by 2a into, now after applying the limits to this we'll get minus t cos at minus 0 by a plus, that is minus of minus becomes plus, and we'll take this 1 by a outside, plus 1 by a, and what will be left? Integral cos au. Integral cos au du is sine au by a within the limit 0 to t. Now this will be equal to 1 by 2a into minus t cos at by a. Now take this a outside. So plus 1 by a square into sine at minus sine 0 is 0. Therefore 1 by 2a into minus that is we'll make the denominator equal to a square. So just multiply the numerator also with a. So minus 80 cos 80 plus sin 80 by a square. Now we'll take this a square outside. It becomes equal to 1 by 2a cube into sin 80 minus 80 cos 80. I hope it's clear. Please do like and share the video and subscribe the channel. Thank you.